at the conventional flow rates of 0.3 and 0.35. Okay, so to sum up, based just actually on that last graph, if you don't remember anything else, this 10 to 15 column volume rule of thumb seems to be a little bit overstated for reverse phase liquid chromatography. The conventional flow rates yielded 5 to 10 column volumes as a typical requirement depending on the column tested. We did find with the columns we studied, and I didn't show you all the preliminary results, that column re-equilibration can be performed more efficiently if we go to a slower flow rate only during the re-equilibration process. So you're not going to slow down your analysis time all that much. Okay. Roughly speaking, the volume of mobile phase required for column re-equilibration, depending on the column that was being used, varied from 25 to 65%. And when you take into account the gradient steepness of the analysis and all the solvent that you use during the actual gradient elution itself, then the savings in solvent consumption by using this approach range from 15 to 50%, which I hope is enough for this paper to qualify as a green chemistry topic. Okay. In future research, we obviously have to look at additional C18, but also a lot of non-C18 columns, like the pentafluorophenyl column, the cyanopropyl column, lots of different columns. We want to look at a lot of the characteristics of stationary phases and mobile phases, including pore diameter, depth, morphology, mobile phase viscosity and temperature, and things like that. And we had been using, in this particular study, the retention time of acetophenone, which is a neutral compound, as our test compound to measure re-equilibration, but we want to consider ionizable compounds in the future. Okay. We also want to look at aqueous or partially aqueous separation modes other than reverse phase liquid chromatography. Those would include ion exchange and, if you're familiar with it, Hillock. Okay. So I want to acknowledge the students who contributed the data to this presentation. That would be 4 full-time PhD students and 1 undergraduate student that you see here. Also, I'd like to acknowledge the grant we got from Agilent Technologies for our low dispersion 1290 HPLC system, as well as the companies that you see here for donating some columns, not all of which we've gotten to yet, so, but we appreciate it. And then the full-time students that contributed are listed here: Donna Blackney, Aaron Ennis, Catherine Keita, Michael Fletcher. This is an undergraduate student who was in the picture, but not one who contributed to the data. That was Pat Carioni. So anyway, thank you very much for your attention.
Okay, I believe we can take one question. If anybody has a question, one question, please. Anybody? Oh, got one right here.
So one of the challenges of working with HPLC, I've been working a lot with sticky molecules, like sticky proteins. Mm-hmm. So the re-equilibration is most of the times is not the next step. Normally, you have to flush your column with a strong solvent to make sure that everything comes out. Mm-hmm. Have you put any thoughts on that, on your strategy, how to reduce, because it's this strong solvent, the one that, right, is our concern.
Right. Depending on the compounds you're looking at, and of course proteins, you're probably not, if you want to keep them from being denatured, you're not really using organic solvent too much, are you? Acetonitrile. So you are using some acetonitrile. Okay. Well, yeah, I'm not completely familiar with protein separations. I would think that yes, if you had to switch to yet a different solvent to completely flush out your column, that would be a distinct disadvantage. On the other hand, there are a lot of gradient analyses based on gradient elution where the final mobile phase composition that you choose is purposely probably 10 or 15% above what you perhaps need to just elute the compounds of your sample, and it's done on purpose that way to make sure that you're eluting other things that could be present as well, not necessarily in the case of protein samples, but other samples.